Welcome back to the Deep Dive. Today we're tackling the Lightning Network. People often call it Bitcoin's fast lane.
Right.
We've got our usual deep stack of research and, well, our goal is really to cut through the noise. We want to understand how this layer 2 tech aims to unlock Bitcoin's potential,
Yeah,
for wider adoption.
exactly. Bitcoin's design, fundamentally, it prioritized security and decentralization above all else.
Uh,
And that meant making trade-offs, speed, transaction capacity. We're talking, what, maybe 3 to 7 transactions per second. Blocks take about 10 minutes on average.
which, yeah, when you think about global payments,
Yeah.
well, it's just not feasible for everything.
But this wasn't an accident, was it? It's that whole scalability trilemma.
That's the win. The challenge of getting decentralization, security, and scalability all maxed out at the same time, it's hard. Bitcoin really leaned into the first two.
Decentralization and security. Yeah. That base layer, secured by proof of work, permissionless. That's the bedrock. Trying to massively speed that up could cause real problems. Maybe more mining centralization, maybe harder for regular folks to run nodes.
Okay, so if you limit the capacity, you inevitably get congestion. That's the Bitcoin mempool everyone talks about.
Right.
And when demand shoots up, so do the fees, because everyone's trying to get their transaction into the next block.
Precisely. It creates this dynamic fee market. And yeah, during busy times, those fees can get pretty high. Sometimes high enough that it just doesn't make sense for small, everyday payments. The fee could cost more than the actual thing you're buying.
Which definitely makes Bitcoin's original vision, peer-to-peer electronic cash, a bit harder to achieve. High fees, long waits. Not ideal for buying coffee.
Not at all.
So this is where layer 2 solutions come in. And the Lightning Network is, well, the big one for Bitcoin. It's designed to boost scalability without messing with that core layer 1 protocol.
Correct. Think of layer 2s like Lightning as building on top of Bitcoin. Their main job is performance boosting speed, handling way more transactions, and doing it much cheaper by taking a lot of the activity off-chain.
Off-chain.
But crucially, they still rely on the security of layer 1, the main Bitcoin blockchain, for the final settlement and, if disputes happen.
So Lightning's promise is pretty compelling then. Near-instant payments,
Yeah.
super low fees, enabling micropayments, and a massive boost in how many transactions Bitcoin can handle overall.
Yeah.
Okay, let's dig into that off-chain idea. How does Lightning actually do that?
Well, the foundation of Lightning is the payment channel. It's basically a direct, private connection set up between two people or two nodes.
A private connection.
Yeah, and this channel lets them send Bitcoin back and forth, potentially many, many times without telling the main Bitcoin network about every single little payment.
Okay, how do you set one up? How do you start this channel?
Yeah, it actually starts with a normal Bitcoin transaction on-chain. So two parties agree, let's open a channel. They create what's called a 2-of-2 multi-signature address on the Bitcoin blockchain.
Multi-signature, meaning both need to sign off.
Exactly. Both need to agree to move the funds. Then they each commit some Bitcoin to this shared address. This funding transaction, that's public. It's recorded on layer 1. That multi-sig is key. Neither person can just run off with the money locked in the channel.
Right, okay. So it's like a joint safe deposit box on the blockchain needing 2 keys.
Right.
Got it. So the Bitcoin's locked. What happens when they want to actually, pay each other within that channel?
Right. So once it's funded, that's when things move off-chain. Let's say Alice wants to send some Bitcoin to Bob within their channel. She doesn't broadcast anything to the whole Bitcoin network.
Okay.
Instead, they just exchange signed messages between themselves. These messages update the balance of who owns what inside that specific channel. They're called commitment transactions.
So like a private tally sheet just between them.
Exactly like that. Every time a payment happens, they create a new commitment transaction showing the updated balances. And importantly, only the latest signed version is the valid one. It cancels out all the previous ones.
Oh.
And this exchange of signed updates happens pretty much instantly, directly between them, no waiting for block confirmations.
And when they're done, maybe they've made dozens of payments back and forth.
Yeah.
How do they settle up and get their Bitcoin back onto the main chain?
Good question. When they decide, okay, let's close this channel, they take that final agreed-upon state, the latest commitment transaction they both signed, and they broadcast that to the Bitcoin blockchain.
Just one transaction?
Just one final settlement transaction. It tells the network, okay, based on all our off-chain activity, here's the final score. The Bitcoin locked in that multi-sig address is then split and sent back to Alice's and Bob's regular wallets according to that final balance.
Wow. So you could have, like, hundreds of payments off-chain, but only 2 transactions ever hit the main Bitcoin blockchain, the opening and the closing one.
That's the core idea. It's a massive reduction in the load on layer 1.
Okay, that makes sense for direct payments. But what if, I want to pay someone, let's call it Carol, but I don't have a channel open with Carol directly. Maybe I only have one with Bob, and Bob has one with Carol.
Yeah, that's obviously crucial for a network effect. And that's where Hashed Timelock Contracts, or HTLCs, come in.
HTLCs, okay. Sounds
Ah,
complex.
smiling slowly. They are quite clever. HTLCs are what make secure, trustless payments possible across multiple hops through intermediaries, like Bob in your example. They basically combine two cryptographic tricks, hash locks and time locks.
Okay, let's break that down. Hash lock, what's that?
A hash lock basically makes a payment conditional. The recipient can only claim the funds if they can reveal a secret piece of data called a preimage. Yeah. The sender, or actually usually the final recipient in a multi-hop payment, generates this secret, this preimage. They then calculate its cryptographic hash like a digital fingerprint. The payment is locked using this hash. The only way to unlock it is to provide the original secret, the preimage that matches the hash.
Why is that secure?
Because it's practically impossible to figure out the secret just by looking at the hash. But if someone gives you a secret, it's super easy to check if it hashes to the right fingerprint. So the hash is like the lock. The preimage is the key.
Okay, that clicks. And the time lock part seems obvious, but
It is pretty much what it sounds like. It sets a deadline, a specific time, or maybe a Bitcoin block height, after which the payment can't be claimed under the original terms anymore. It's a safety mechanism.
wow, so.
It prevents funds from getting stuck forever if, say, the recipient never reveals the secret or someone along the route goes offline. If the deadline passes, the funds can be reclaimed by the sender.
Got it. So how do these two things, the hash lock and the time lock, work together in that Alice pays Carol via Bob scenario?
Okay, let's walk through it. Carol wants to get paid, so she generates the secret preimage, let's call it R, and calculates its hash, H. She gives the hash H to Alice, the person paying.
Okay, Alice has the hash, but not the secret.
Right. Alice wants to pay Carol, but only has a channel with Bob. So Alice sets up an HTLC payment to Bob. It essentially says, Bob, you can claim these funds from me if you provide the secret R that matches this hash H before this specific deadline, say time X.
Okay, so Bob now has an incentive. He wants to get paid by Alice, so he needs to find that secret R.
Exactly. But he doesn't have it yet. So Bob looks at his channel with Carol. He then creates his own HTLC payment to Carol. This one says, Carol, you can claim these funds from me if you provide the secret R, the same one matching hash H, but before an earlier deadline, say time Y. Time Y has to be before time X.
Ah, the deadlines cascade backwards. So Carol sees she can get paid by Bob if she reveals R before time Y.
Precisely. So Carol reveals R to Bob, claims her funds from him. Now Bob has the secret R.
And Bob can now go back to Alice.
And reveal R to Alice before his deadline, time X, and claim the funds Alice promised him. The payment flows Alice, Baba's Carol. The secret R flows Carol, Maba's Bob, Alice.
That's actually really elegant.
It is. And the time locks ensure that if anyone messes up or disappears, the funds eventually roll back safely. It works without needing to trust the intermediaries.
Very cool. And for privacy in these chains of payments, there's something called onion routing, like Tor.
Yeah, very similar concept. Onion routing adds a privacy layer. When Alice sets up the payment to Carol via Bob, the instructions are wrapped in layers of encryption, like an onion.
Okay.
Bob, the intermediary, can only decrypt his layer. That layer tells him only where to send the payment next to Carol and the HTLC conditions for his hop. He doesn't know Alice was the original sender or that Carol is the final destination. He just sees the person before him and the person after him.
Like passing along sealed envelopes. Each person only opens the outer one addressed to them. That definitely boosts privacy. Any downsides?
Well, there's maybe a slight trade-off with routing efficiency sometimes. Since the sender sets up the whole encrypted path, if a payment fails somewhere, maybe a channel lack funds trying again might accidentally reveal a tiny bit about the network state. It's a balance.
Makes sense. And the nodes doing all this work, like Bob, routing payments and locking up their Bitcoin.
Yeah,
They need a reason to do it, right? Fees.
absolutely. Routing nodes charge small fees for their service, usually two parts. A tiny fixed base fee for just handling the payment, no matter the size.
Right.
And a fee rate, which is proportional to the amount being sent, often measured in something super small, like parts per million. These fees incentivize people to run nodes and provide the liquidity that makes the network function.
So base fee covers the hassle. Fee rate covers locking up capital. Seems reasonable. But running a node profitably sounds like it might be tricky, managing that liquidity.
It definitely can be. It requires capital, some technical know-how, keeping channels balanced.
Yeah.
It's not passive income necessarily. And this does lead to some concerns, about whether the network might centralize around a few big, efficient routing hubs.
We'll definitely come back to challenges like that. But first, let's focus on the upsides. What are the big advantages Lightning brings?
The absolute headline is speed. Lightning payments are practically instant. Milliseconds, maybe a few seconds. Compare that to Bitcoin's 10-plus minute average block time. It's just night and day.
Yeah, that's a huge difference.
There was a Fidelity Digital Assets report, I think from early 2025, mentioning that most payments under, say, zero point 0.01 Bitcoin achieve near instant finality on Lightning.
That kind of speed changes everything for usability. Waiting 10 minutes isn't practical for most daily purchases.
Yeah.
And the fees, too, you mentioned they're much lower.
Drastically lower, often fractions of a cent. This is what really unlocks micropayments, sending tiny amounts of value economically.
Things that were just impossible before because the fee would be more than the payment.
Exactly. That same Fidelity report suggested fees could be near zero or under 0.5% for many Lightning transactions. This speed and low cost enables totally new things, tipping creators directly, paying for streaming by the second, maybe even machines paying each other for data or services in the IoT world.
It really starts to sound like that Internet of Value people talk about, sending tiny bits of money instantly. And from a pure scaling perspective, moving all this off the main chain must help Bitcoin handle more users.
It's a massive improvement. Layer 1 is limited, 3TAS, 7 TPS maybe. Lightning, theoretically, could handle millions of transactions per second across the whole network. That's how you scale to potentially global levels.
Right.
Plus, it helps reduce what they call blockchain bloat. Fewer transactions cluttering up the main chain helps keep Bitcoin sustainable long term.
And the privacy aspect. We touched on onion routing.
Yeah, that's another advantage. Compared to everything being on the public Bitcoin ledger, Lightning offers more privacy.
Yeah.
The transactions inside a channel are just between the two parties. And the onion routing for payments that go across multiple hops adds another layer of obfuscation, making it harder to link senders and receivers. It's not perfect anonymity, but it's a significant improvement over layer 1.
Okay, so speed, low fees, scalability, better privacy. The benefits are clear, but like any technology, especially a newer one, there must be hurdles. What are the main challenges or limitations facing Lightning?
Definitely. One of the big ones is liquidity management. For your payment to get through, especially across multiple hops, there needs to be enough Bitcoin capacity pointing in the right direction in every channel along the path.
So channels can become unbalanced.
Exactly. If all the money in a channel between Alice and Bob is on Bob's side, Alice can't send any more to Bob through that channel until Bob sends some back or they rebalance somehow. Keeping channels balanced takes effort, and making really large payments can sometimes fail if there isn't a path with enough capacity the whole way.
And for new users getting started,
Yeah.
they need someone to open a channel to them first, right? The bound liquidity problem.
That's a classic onboarding challenge. You need someone to push some funds to your side of a channel before you can receive payments easily. There are services that help with this, but it's an extra step. Active management is often needed.
Okay, liquidity is tricky. What about just finding a path? The routing itself.
Yeah, routing can be complex. Finding the best path isn't always simple, and payments can fail for other reasons too. Maybe an intermediate node is offline, or there's just a temporary glitch.
So payments aren't guaranteed to succeed.
Not 100% guaranteed, especially for longer routes with more hops. The success rates are improving, though. Fidelity mentioned around 95% success for smaller payments, and it's often higher, like over 99%, for simpler direct payments or routes handled by good service providers. But failures still happen.
And I've heard you kind of need to be online or have someone watching your channels for you.
Ideally, yes. You need to monitor your channels to make sure your counterparty doesn't try to cheat you by broadcasting an old channel state, like one where they had more money.
What if you're offline?
That's where watchtowers come in. These are third-party services you can basically hire to watch your channels while you're offline. If they see foul play, they can automatically step in and broadcast a penalty transaction to protect your funds.
But that means trusting a third party again.
It does. It's a trade-off. Convenience versus complete self-reliance and needing to stay vigilant yourself or run your own monitoring setup.
Okay. Any specific security risks or ways people might attack the network itself?
There are known potential issues, yeah. Things like channel jamming, where attackers try to clog up channels with fake or slow payments to disrupt routing. griefing attacks that just aim to annoy people.
Uh-huh.
There's always the risk of a node itself being compromised, keys stolen. And a more theoretical risk is a mass closure event where maybe lots of HTLCs expire at once, potentially flooding the main Bitcoin network with transactions. Developers are constantly working on defenses against these things.
And just for the average person, the user experience, setting up channels, managing liquidity, it still sounds maybe a bit intimidating compared to just using Venmo or something.
That's definitely been a barrier, absolutely. The concepts are different, but the UX is improving dramatically. Wallet developers are doing a great job abstracting away the complexity.
How so?
You have custodial wallets, like Wallet of Satoshi or Strike, where they handle all the channel stuff behind the scenes. Super easy, but they hold your keys.
Right, the usual trade-off.
Then you have non-custodial ones where you hold the keys, like Breeze or Phoenix, that are getting really good at automating channel creation and management, so you get the self-custody benefit with a much simpler experience. Mune, Zap, Exodus, Blue Wallet are others. Lots of innovation happening there.
That's good to hear. What about the centralization concern we touched on earlier? Big routing nodes dominating.
It's still a valid concern, yeah. The economics might favor larger players, Lightning Service Providers or LSPs, who can offer lots of liquidity and reliable routing. If too much activity flows through just a few big hubs, it could chip away at the decentralized nature of the system. The community is aware of this and looking at ways to encourage a more distributed network.
And one last point on challenges.
Mm-hmm.
Fees. Okay, Lightning fees are tiny, but you still pay Bitcoin network fees to open and close channels, right? So has Lightning actually made using Bitcoin cheaper overall?
That's a really good question, and it's kind of nuanced. Yes, for the actual payments flowing within a channel, especially if you make many of them, the cost saving is huge compared to doing each one on-chain.
Right.
But those on-chain fees for opening and closing do exist. And if Bitcoin's main network fees are high when you need to open or close, that cost is still there. So Lightning is fantastic for frequent users or micropayments, but it doesn't eliminate on-chain fees entirely.
And the routing fees themselves, could they get too low?
That's another angle. If competition drives routing fees down to almost nothing, maybe nodes won't have enough incentive to provide the liquidity the network needs. Kind of a potential tragedy of the commons situation. It's a balancing act.
Okay, quite a few things to keep an eye on there. Let's switch gears, though, to the exciting part. Where is Lightning actually being used out in the wild today?
We're seeing it pop up in some really interesting places. Micropayments are definitely a big one. You see it on social platforms like Nostr with Zaps for instant tipping.
Zaps, yeah, I've seen those.
Podcasting 2.0 uses it. Services like WaveLake let you stream tiny Bitcoin payments, boosts, directly to creators as you listen, paying for individual articles online instead of a whole subscription. There's even this cool project in El Salvador, Torgos Pay, that uses Lightning to automatically split payments along a supply chain.
Wow, that's clever. Automatically paying the farmer, the distributor, the retailer.
Exactly, based on pre-agreed splits instantly.
Yeah.
Shows the potential for really granular value flows.
What other areas?
Gaming is a natural fit. Fast, cheap, in-game item purchases or rewards, digital content generally. Global remittances is another powerful one.
Right, sending money across borders.
Companies like Strike use Lightning to make international transfers much faster and way cheaper than traditional methods. That can be huge, especially for people in developing countries sending money home. Paxful also integrated it in Africa.
And just regular shopping. Retail, e-commerce.
It's starting to gain traction there, too. Lower fees and faster settlement times are attractive for merchants. Still early days for broad adoption, but the potential is clear.
And you mentioned El Salvador.
Okay.
That's kind of the big test case, isn't it? Bitcoin is legal tender, powered by Lightning for daily use.
It absolutely is. It's a fascinating real-world experiment. The government's Chivo wallet relies heavily on Lightning. And in places like El Zonte, the original Bitcoin beach, people have been using Lightning for everyday stuff, groceries, bills, coffee for a while now. We're learning a lot from their experience.
Definitely a space to watch. So, zooming out a bit, what does the overall Lightning ecosystem look like now, say early 2025? How healthy is it?
It's grown significantly. Looking at public data, channel capacity, Fidelity's report mentioned around 5,358 Bitcoin locked in public channels. That's over $500 million USD at recent prices, a huge jump from just a few years ago.
And that's just public channels.
Right. Live trackers like 1ml.com might show slightly different numbers, maybe a bit lower, like 4,200 BTC, because the network is dynamic. But critically, none of these public stats include private channels, which could hold a lot more capacity we just can't see.
Okay. What about the number of nodes and channels themselves?
Fidelity pegged public nodes somewhere around 16,000, 17,000, and maybe 75,000 public channels. Again, live trackers might show lower counts like 11,000 nodes, 42,000 channels. What's interesting is a trend towards maybe fewer channels overall, but the average channel is getting larger and nodes are becoming better connected. Seems like the network is maturing, becoming more efficient.
And transaction volume. Is there any way to know how much is actually moving across Lightning?
That's the tricky part with off-chain privacy. There's no single public number for total volume. But we get clues. Big node operators, Lightning service providers like Voltage, they report substantial growth in the payments they're routing.
And success rates. Are payments getting through more reliably?
Yes, definitely improving. That Fidelity data suggested around 95% success for smaller payments, and for direct payments or using well-run LSPs, it's often much higher, over 99%. The longer, more complex routes through less reliable nodes are still where you see more failures, but it's getting better.
Okay, the plumbing is getting stronger. And the tools people use, the wallets,
That ecosystem is booming. We talked about custodial ones like Wallet of Satoshi and Strike, super simple, great for beginners.
but they hold your keys.
Right. Then the non-custodial options are getting way better. Breeze, Phoenix, they handle a lot of the channel management automatically now, which is huge for usability while letting you keep control of your funds. Plus Mune, Zap, Exodus, Blue Wallet, lots of choices, some letting you connect to your own node if you want to go full sovereign.
And it's not just apps. Big crypto exchanges are getting involved too.
Yeah, that's a big deal for adoption. Exchanges like Kraken, Coinbase, Binance, Bitfinex, they now support Lightning deposits and withdrawals.
So it's easier to move Bitcoin onto and off of Lightning.
Exactly. Faster, cheaper on-ramps and off-ramps. It also adds a ton of liquidity to the network. The flip side, again, is that it might concentrate some liquidity and influence with these big exchange platforms. Another centralization pressure point to watch.
So the ecosystem is definitely growing and maturing. But what's next? What exciting developments are on the horizon for Lightning?
Oh, there's lots of cool stuff being worked on. Technologically, things like atomic multipath payments or AMP. Yeah, it lets you split a single large payment across multiple smaller paths simultaneously, makes bigger payments more reliable, and potentially increases the effective capacity you can send.
That sounds useful.
Then there's channel splicing. This would let you resize an existing channel, add more Bitcoin, or take some out with just one on-chain transaction instead of having to close and reopen a whole new channel. Much more flexible.
Nice. More efficient.
There's work on security, like validating Lightning Signer, VLS, which aims to separate your private keys from your main node software for better protection. And a really big one is Taproot assets.
Taproot assets.
Yeah.
What does that enable?
It opens the door to issuing and transacting other kinds of assets, not just Bitcoin, over Lightning. Think stablecoins like Tether, USDT, running on Lightning.
Wow, stablecoins on Lightning. That could be huge for payments, avoiding Bitcoin volatility day to day.
Exactly. That's a major potential use case. Plus, loads of infrastructure work projects like Greenlight making it easier to run nodes, Blast for simulating network conditions, new node software like Lampo, testing tools like Elm Prototest, all making the network stronger and easier to build on.
It sounds like the foundations are still being actively built and improved. What about entirely new types of applications, like DeFi on Lightning?
There's definitely talk and early exploration there. Could we see lending or borrowing using Lightning channels? Maybe earning a yield on your Bitcoin just by providing routing liquidity. People sometimes call that native yield. Still early days, but the potential is there as the network gets more robust.
And for it to really take off with average folks, that user experience just has to keep getting simpler.
Absolutely critical. Continued improvements in wallets, more automation, things like Lightning addresses, which look like email addresses but for receiving Lightning payments, and LNURL standards, making interactions smoother. It all needs to feel as easy as the payment apps people use today.
And as it gets easier and more reliable, presumably institutions might get more interested too.
That's the expectation. As the tech matures, financial institutions might start looking at Lightning seriously for things like remittances, faster settlement between institutions, maybe entirely new financial services. Fidelity's report certainly predicted continued integration.
Okay, so wrapping this up, it really feels like the Lightning Network is a crucial piece of the puzzle for Bitcoin's future. It offers a credible way to overcome those built-in scaling limits.
I think that's right. It fundamentally changes the equation for Bitcoin's speed, cost, and overall usefulness, making it viable for so much more than just large occasional transfers.
It boosts the speed, slashes the fees, increases the capacity,
Yeah.
really tackles the main criticisms head-on.
Exactly. Now, challenges definitely remain. Liquidity, UX, routing reliability, potential centralization. These are real issues being actively worked on. But the pace of innovation is incredibly fast.
It really seems like this layered approach, Bitcoin as a secure settlement layer,
Right.
Lightning as the fast payment layer, is proving to be a powerful combination.
Yeah.
It makes Bitcoin much more adaptable.
It does. It strengthens Bitcoin's position significantly. It's not just about scaling, it's about expanding the possibilities of what you can do with Bitcoin.
And it really makes you think, doesn't it? How could this combination of a secure base and a super fast layer on top change not just how we send money day to day, but maybe even the fundamental nature of money and value transfer online? Lots to consider there. Thanks for diving deep into Lightning with us today.